What happens when you put dish soap in a dishwasher? A teachable moment about surface tension.
A while back, my daughter couldn't find the dishwasher detergent and decided to use dish soap instead. I got very excited when I saw what happened because I realized that this was a teachable moment about surface tension. I'll show you what I mean.
Warning: do not try this at home unless, like me, you have a cruddy floor and a strong interest in detergent chemistry. This is what happened about 10 minutes into the cycle. Why? I'll tell you after I clean up.
If, after watching this video, you still decide to try this at home, a turkey baster works really well for getting the water out. Now for the big question. Why is dish soap so different than dishwasher detergent? And what does this have to do with surface tension? To answer this question, we'll take a look at a water molecule.
A water molecule is like a tiny magnet. One end has a somewhat negative charge, and the other end has a somewhat positive charge. Like magnets, water molecules are attracted to each other. This makes the molecules happy. Water molecules at the surface don't have other molecules to latch onto. This makes the molecules sad. To maximize the number of happy water molecules, water arranges itself to minimize exposure to air. This tendency to minimize exposed surface area is called surface tension. Raindrops are round because a round shape minimizes exposure to air. Because of water's high surface tension, water striders can skim the surface of a pond. Thanks to surface tension, water normally stays in my dishwasher. The water molecules can't get through the gasket because they clump together, just like raindrops. When I used dish soap, water didn't stay in my dishwasher. This is because dish soap contains strong surfactants, which are substances that lower the surface tension of water. Surfactant literally means surface acting agent. Dishwasher detergent contains surfactants too, but they aren't as strong as the ones in dish soap. A surfactant molecule has two ends. One end is loved by water. The other end is feared by water. Surfactant molecules arrange themselves in little spheres, so the water-fearing end is shielded. At the surface, the water-fearing ends stick up in the air. Since the water molecules are shielded from air, they are more willing to spread out. I'll do an experiment to show you this in action. I'm going to count how many drops of water a penny can hold. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. 26 drops of water. Now I'm going to repeat the experiment with dish soap. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And there it started leaking off at 15, so that's 14 drops. Pure water mounds a lot because water has a high surface tension and is trying to minimize contact with air. Soapy water doesn't mound as much because the surface tension has been reduced. Soap protects the water molecules from air, so they are more willing to spread out. Surfactants are good for cleaning because they allow water to spread out, which means it can soak its way into crud that's, say, on the surface of a dish. Greasy bits end up in the water-fearing part of the surfactant and can be easily washed away.
Some surfactants are so good at shielding water they can form bubbles. In a bubble, a thin layer of water is sandwiched between two layers of surfactant. Scientists have played around a lot to change the properties of detergents, and you can play around too. You can add corn syrup to soapy water to make a better bubble mix. I'll show you. This is plain soapy water. And it makes pretty good bubbles, but they pop pretty easily. And this is soapy water with corn syrup. When I add corn syrup to the dish soap, the bubbles last a lot longer. That's all I have to say about surface tension. For links to fun experiments with surface tension and other inspiring ideas, visit my website, www.andreahazard.com.